Okay, so now we're going to look at functions. So, let's just say this. So you have it in your notes and you go back and read it easy. Let's look at a particular type of relation. And what does a relation mean? A relation is a set of ordered pairs. So the particular type that we want to look at here of a relation is called a function. Is called a function. All right, that's the definition I'm going to write. So a function, and to keep it as simple as possible, a function is simply each x value has exactly one y value. Each x value has exactly one y value. Or in other words, remember, x values were also known as inputs, and y values were known as outputs. So if you had, it simply means one input, one output. All right, I'm going to show some examples of a function and not functions, and hopefully this is going to make it a little clearer. So give yourself some room here. I'm going to do functions on this side and no non-functions on this side. So just be able to write two separate tables next to each other. That will be helpful. So let's call these the functions. And then over here, I'm going to say not functions. So I'm going to give a function here. So let's write a relation. 1, 2, 3, 4, and the square root of 7, pi. That is a function. It's a function because each x value has exactly one y value. So this input of 1 has an output of 2. And there are no other 1s anywhere here in the domain. Here this 3 has an output of 4, and there's no other 3s in the input sections. All right, same thing here. But what I want to do now is I want to take the same exact setup and change one number to make it not a function. So number 1 over here. And there are infinitely many ways to make this not a function. All I have to do is change one of these x values, and then it makes it not a function. But what do I need to change the x value to make it not a function? So I need to make one of these x values the same. So what I'm going to do is I'm going to change this 3 right here to a 1. Let's look at it. So now I have 1, 2, 1, 4, and the square root of 7, pi. So the only thing I changed was this 1 right here. And now if I look at this not function, I see that I have an x value in both of these pairs, and they go to different y values. This is not a function, because 1 cannot go to 2 and 1 cannot go to 4 at the same time. That makes it not a function. All right, you try one. I'm going to give you a function, and then you're going to make it not a function. Let's see here. Let's say number 2, 6, 8, 5, 12, and -3, -2. All right. So I want you to try to make this not a function. All you have to do is change one x value so that they'll match. And it doesn't matter which one you change. Again, there are infinitely many of these. So what I'll do is I'll change this 6 to a -3. And now I'm going to have the input of -3. I'm going to have the input of -3 giving me two different values, which is an invalid. So this 6 is going to become a -3 now. -3, 8, and then everything else is the same. Okay. There are a couple other functions we need to be aware of. So let's look at this. Let's say we had, let's say we had 6, 8. I'm going to do the same thing up here, except I'm going to add 1 to it. And then let's add 6, 8. So notice here, so I don't get things confused. Notice here in 3 that we have 6, 8 and 6, 8 written twice. So does this make it a function or not a function? Well, I wrote it in the function section, so you probably already know it's a function. If it's written twice like this, it's just redundant. It doesn't mean anything. As long as you still have the same x value going to the same y value, it doesn't matter if they're written twice. This is the same exact thing as writing this. All right, so this is still a function. And I'm not going to worry about writing a not function for this. You can do it yourself if you want. And then one more thing let's look at. And I want you to determine if this is a function or not. So, example 1 is this a function? Part A. Let's say we have 6, 8 again, and 5, 12, and -3, -2, and the only thing I'm going to change this time is this last one, and let's call it 5, 8. So when we determine if something's a function, we need to look at all the x values and see if the x values repeat. And do any of the x values repeat? Yes, they do. This 5 goes to 12, but this 5 goes to 8. So that makes it not a function. Not a function. Let's look at another. B. 1, 2, 3, 4, 5 comma 2, and we'll just leave it at that. So is this a function? Well, do any of your x values repeat? No, they don't. So that would make it a function. But why did I write this on the board, and why is this one confusing, or potentially confusing? It's potentially confusing because you have the same y values here. But that's not an issue here. So even if you have the same y values, that's okay. It's as long as your x values don't repeat and you have a different output. So yes, a function. All right, what are some real-world examples of a function? Hopefully this will help a little bit. Real-world examples of functions. All right. So brainstorm a bit, maybe watch one or two of these, see if you can come up with one. All right. A good one is social security numbers. To people. So let's say the inputs are us, the people. So you input my name, Fort, and it outputs a specific social security number. So the input is me, the output is a social security number. Or you can do it vice versa too here actually. If you input a specific social security number, output would be my name. And same thing for everybody else in the world. You have a social security number, it's input, and then the output is that person's name. So if you ever have a social security number that's tied to me, Fort, and then a social security number that's tied to, say, my wife, then that's an issue. It's an even bigger issue if you have a social security number tied to me, and then someone from someone completely I don't even know. So that's a great example. Another one is bank account. Bank accounts to person/family. So you can have one account for, a wife and a husband, say. And then 3, you could have barcodes. Say at like a grocery store. So you're in the checkout line at Target, and you have 2 gallons of milk, so 1 gallon each. You have 2 milks, and you have eggs and strawberries. You scan the strawberries, they're $18. You scan the eggs, they're $17. Then you scan your first milk, and it's $9. And then you scan your second milk, and it's $18. The milks are the same, but you're getting 2 different output values. So that's an example of not a function, if those barcodes didn't line up. So if you scan the same item, but you get 2 different prices, then you're going to throw a fit at Target or wherever you're at buying your milk. The milk should be the same price. So that's kind of where functions come into play and how they're used in the real world.